You may think that that is my 2020 in a single video, but actually, that's some rocket launching space stuff, and we're going to learn all about it. Astromotive is creating a last mile on demand orbital delivery service for small satellites. So think of this new class of tiny on demand rocket launchers are the equivalent of Uber, but for space. Their cutting edge technology provides transportation for small satellites to travel to low gravity worlds, including the moon and Mars, which is advancing the space exploration market. Founder Lawrence Sheets is here to tell us how. Hi, Lawrence.
Shannon, thank you so much for the amazing introduction. I also just want to begin by thanking everyone at EDCO for hosting PubTalk and also for the opportunity to present tonight. So yeah, Astromotive is my startup, and we are building a last mile delivery service for small satellites in space. And that video that you just saw was from October, and it was our first successful test firing of the rocket engine that we'll use to power our spaceship. And from the video, it might be difficult to get a sense of scale. So this is basically how big the engine is. It's 3D printed in stainless steel, and it will produce about up to 1,000 pounds of thrust for this prototype. And so for me, as a self-taught software developer who doesn't have any formal engineering background, I was fortunate enough to have worked for a rocket company in Portland for several years, going back to 2017, doing some software engineering. And I learned a lot about the satellite launch market and some of the problems that have yet to be solved. And ultimately, that's how Astromotive came to be. So yeah, the problem that Astromotive is addressing is CubeSat orbital placement. CubeSats are these tiny modular satellites, about the size of a toaster. They weigh only a couple of pounds, and they're being built literally by the thousands to do all sorts of interesting things in space, like provide global internet or get high resolution imagery of every square foot of Earth's surface every day, or just doing experiments that are unique to the environment of space. Basically things that provide value to almost every industry on Earth. But there's a big problem. Many of these CubeSats, they need to get to a precise location in orbit. But typically they have to share a ride to space with a much larger primary satellite customer, and they just get dropped off wherever those are going. And so to solve this problem, there's this new class of small rockets called micro launchers, and they're aiming to provide an Uber-like service, launching CubeSats on demand to a precise destination. The downside is that this solution is actually incredibly expensive. The current micro launch leader, a company called Rocket Labs, they charge around $12,000 per pound for their launch services. And by contrast, SpaceX's fully reusable Starship rocket that could launch commercially later this year, it's projected to cost less than $100 per pound of payload launched. So we asked the question, what if it were possible to get both the Uber-like delivery services of these micro launchers and the incredibly low costs of reusable heavy lift rockets? And so Astromotive's goal is to make this possible. So our solution, we're building essentially a delivery van in space. It's a vehicle that will take these CubeSats, the proverbial last mile, to their desired orbital destinations. A hypothetical mission would consist of 1,000 pounds of payload. This could be something like 50 20-pound CubeSats dropping off 10 at a time to 5 different orbital altitudes or inclinations. And as you've seen, we've prototyped and fired the propulsion system, and we're going to continue to build our spacecraft around the propulsion system that we've developed. We're aiming to capture a significant share of the small satellite market, which has grown at an annual rate of 23% for the past decade and is expected to actually accelerate going into the 2020s. It's projected to be a $10 billion market in 2027. So our customers, they want low-cost, precise orbital placement and on-demand service, and our solution is the right approach to providing all these benefits. Gwynne Shotwell, SpaceX's president, said just a few weeks ago that vehicles like the ones we're developing are a perfect market opportunity and could be a major disruptive force in the small satellite launch sector. we do have a few competitors, but since most of the focus has been on these micro launchers, the number of direct competitors is still very small. And when we're looking at our competitor solutions, it's clear to us that their design assumptions are based on the currently relatively high cost of launch. And this assumption impacts things like the size of the spacecraft they're building, the type of propulsion system they're using, overall payload capacity, et cetera. But since the market is actually trending towards exponentially lower launch costs, our solution is going to look a bit different than our competitors. And we think in the end, it will end up better serving our customers. We're also designing reusability into our solution. It's something that will make us unique. So at the end of a mission, our vehicle will dock with a propellant depot, basically a gas station in space, and refuel while waiting for another batch of satellites to launch. Other startups are working on this gas station in space concept right now, and we're partnering with them to be one of the first companies to implement this innovative approach. If we don't have to throw away our vehicle after every mission, then that's just more cost savings to our customers. So right now, Astromotive, it's just me and my co-founder, Andrew Larson, who handles business development. Andrew has an extensive network in the aerospace industry. He managed business development and strategic partnerships at both the Pacific Northwest Defense Coalition and the Pacific Northwest Aerospace Alliance. And then we also have two technical advisors, Andrew Greenberg, an adjunct professor at Portland State University and one of the original founders of the Portland State Aerospace Society. They've been launching high-powered rockets for 20 years. And then Eric Ward, a mechanical engineer from Oregon State, who got his master's in system architecture from MIT, and he currently works at another space startup called Made in Space. And so we have an ambitious 18 months of development ahead. We're going to be working on engine restarts, which is basically firing it multiple times in rapid succession, thrust vectoring, or basically steering it, and then throttling control. And all of these are critical for moving things around in orbit. Once we've gotten those things down, we'll do a full vehicle build and followed by a demonstration mission. And finally, our first customer mission we're anticipating in 2023. So in 5 years, we think we could reasonably be doing about one mission per month, and charging $1,500 per pound would put mission revenue at $1.5 million for an annual revenue of $18 million in 2026. So there are a few things that will help us achieve our near-term goals, and a big one is funding. So far, Astromotive has been entirely self-funded, but we are planning a raise soon. So any accredited investors that are listening are more than welcome to contact us if they want more information. Also, we're looking to add additional team members, specifically in engineering roles. That could be mechanical engineers, electrical, or software engineering. We'd like to hear from anybody who is interested in contributing. And that pretty much concludes my presentation. Thank you for listening, and I'm happy to answer questions.
Thanks, Lawrence. So as a reminder for those folks tuning in from home, you're welcome to type any questions or comments into the chat bar to the right of your screen, and those will find their way to me, and then we can include you in our presentation. So Lawrence, if I understand this correctly, you've essentially created the Kia Soul of space vehicles. This is like a very affordable option. This is what's setting you aside. Do I have that right?
Yeah, we're definitely trying to do the more cost-effective vehicle. Typically, these spacecraft are very, very expensive because if it's super expensive to launch, it really doesn't make much of a difference how expensive or souped up your spaceship is. But all of that is changing, and we're going to be innovating in that sense. So low cost, affordable access to space.
Very cool. I feel like you're speaking in metaphor right now for the larger theme of life right now. What's been the most exciting thing about this project? This is so different than what we are mostly talking about here at PubTalk. So
the most exciting thing to me is someone, like I mentioned, I don't come from the aerospace industry. I haven't worked at SpaceX or for NASA. I'm wearing my NASA shirt, but I just got into this because I was super passionate about it, and I was just doubtful that I could actually do something. And as this has been developing and having a successful firing of the engine is such a huge I guess, accomplishment. And it was like, it's super exciting. The video does not do it justice. When you're like standing 100 feet away from that, and it lights up, it's just like, you get knocked backwards just by how powerful it is. And so that day was just super awesome. And we've had a lot of firings since then that have gotten better and better. And so, yeah, it's the kind of being in the progress of it is super exciting.
I'll bet. Yeah, it's incredible. I mean, I'm sure that is like I have no orientation for how to contribute anything to space, and so I appreciate what you're sharing there. That's really cool. I applaud you. So we have a question from the audience: are there larger companies investing in these smaller applications to help seed the industry's development, like GE does for 3D printing, for example?
Yeah, there are some of the bigger aerospace players. They sometimes have internal sort of like venture arms where they will invest in up and coming companies that are developing innovative technologies and solutions. And so those are some of the conversations that we're going to be having. And yeah, I hope that answers the question.
Yeah,
Yeah, and then also just other strategic partnerships as well in terms of technology licensing, stuff like that.
sure. Yeah, that makes sense. Okay, and where are the missions based?
Where are the missions based? I mean, I'm going to try to answer this question in the way that I would understand it. The missions would launch from wherever the launch provider is launching from. So Cape Canaveral or any of the other commercial launch facilities. And then we're targeting what's called low Earth orbit, which is about 300 to 1,000 miles above the atmosphere or above the surface of the Earth. So that's considered low Earth orbit. There's a lot of activity for these CubeSats in low Earth orbit. So yeah, that's like our delivery neighborhood almost, going door to door to all these different orbits and dropping off packages. So
Yeah, that's great. I love that. That helps a lot. Okay, so what type of regulatory hurdles are you having to overcome?
the big one for startups is in this industry when you're dealing with rockets is ITAR. ITAR controls the flow and the dissemination of munitions, and rockets fall into that category. So you have to be careful and very compliant about the technical data, like how to actually build these sorts of things. They can't be exported without a license, and that includes potentially hosting data on the internet. In your cloud servers, you have to be set up on the right types of services. That way, you're complying with those regulations. So that's probably the biggest one.
Yeah, that makes sense. I have another question from the audience. How are you also undertaking development of the remote control technology and system or technology system?
Yeah, I mean, there are some, I guess, off the shelf solutions to that now, and so a lot of the components can be sourced from different providers. We're building the propulsion system in house because that's one of the more technically challenging things to develop. But we think that's going to be advantageous strategically in the long term to have that be vertically integrated. But like, how do you remotely communicate and send commands to your spaceship? There's actually companies that are just building basic internet portals, like dashboards that you can just type in commands and it sends it to their servers, and their servers have like a little satellite dish and they just beam it up to your spaceship. And so yeah, we're using those other types of solutions. We're not building everything in house. That would be unrealistic.
That's great. I love that you're like, just beam it up. So that's my new motto. Just beam it up. Just beam it up. Okay. One last question for you, Lawrence. Thoughts on aliens?
Thoughts on aliens? I think so.
I think so too. And also, like, help us out. Right?
I think it's more likely than not that there's other life in the universe. Whether or not we've been contacted by it, I'm on the fence about that. But it would not surprise me if we discovered signals coming from other other star systems or in the future. Like that would be shocking to me, I guess.
Yeah, I think I'm with you. I think when if I know anything about like the history of humankind, I'm like, there's got to be more to this than just us. So,
Yeah.
well, Lawrence, it's wonderful to have you. I hope you'll keep us posted. I'm wishing you the best of luck. And hey, feel free to use my whole comparison to the Kia Soul for
All
your
right.
investor seeking. Those things go and go and go, and I can confirm that. Thanks for being here, Lawrence. It's
All
great
right.
to
Thanks,
have you.
Jen.